23. So this one, take a look. It has that symbol triangle PQR is similar to triangle FGH. So this one has to do with our scale factor, our similarity unit. So if you want to redraw the triangle, you can so that they're in the right orientation. They're in the same orientation at least. So if I wanted to, I could, but for me, I can kind of tell which one is which, or I can just use the letters. But for me, I'm going to take a look and see if I can find my scale factor. I look at PR, so that's the first and last letter. So that's going to be F and H. So this 4 right here. And for me, I'm just going to put this shape on top, this one on the bottom. It doesn't really matter. But our scale factor for this question, you could say is 2 over 4, but I'm going to simplify that to 1/2. Now I want to find what QR is. So QR is this side here. That's our last two letters. So that's going to match up with GH, our last two letters as well. So 6x plus 2. So if I put x plus 3 over 6x plus 2, it should be equal to 1/2. And then here you can multiply by 2, cross multiply, multiply by 6x plus 2. What you end up getting is 2x plus 6 is equal to 6x plus 2. And now you want to solve. You have x's on both sides. I'm going to subtract the 2x here, but you could subtract the 6x. Then you'll get 6 is equal to 4x plus 2. I'm going to subtract the 2, subtract the 2. And you get 4 is equal to 4x, divide by 4, divide by 4. So you get x is equal to 1. And so you're not quite done because you do have to find QR. So just plug it back in, 1 plus 3. QR is equal to 4. You could find HG if you wanted to. You get 8 and put it as a scale factor. You'll get 1/2 again. But QR is 4, and that's all you need. All right, 24 here. This one asks which similarity theorem can be used to show that the two triangles are similar. So if you take a look, there's a couple pieces of information. We know that these two lines are parallel. We have these sides here. We do not have this side here, so we're missing one, kind of. And then we do know that vertical angles are going to be congruent. So out of the similarity theorems that we could use, well, the one that's close is we have, side, side, side. We have side, angle, side. We have angle, angle. And there's one more, but these ones are the ones that I can see so far. So here we don't quite have side and then an angle and a side because we're missing this side here. We don't have side, side, side because we don't have three sides that are similar. The only one that works here is angle, angle. And the reason why we could do that is because this angle here is going to be congruent to this angle here because the two lines are parallel and these two angles are, well, alternate interior angles. So this one, in this case, it's going to be angle, angle, similarity theorem. And I guess I will write out theorem for you. And so if we know that the two triangles are similar, we could find out what BC is. So this length here. So I'm going to put my 4 and 7 as a scale factor. I'm going to put it as 7 over 4. You could put it as 4 over 7. But just be careful. I put this shape on top. This shape is on the bottom. So 5 is going to go on top. X is going to be on the bottom. And then you could cross multiply. What you end up getting is x is equal to 20 over 7. Or, sorry, I jumped a step. You get 7x is equal to 20. Divide by 7. Divide by 7. So what you end up getting is x is equal to 20 over 7, or in other words, about 2.9. All right, 26 here. Juan is casting a shadow. So here's Juan. He's casting a shadow that is 1.3 meters, and he is 1.9 meters tall. My picture is very off scale, but that's okay. There's a wind turbine, so it might have like those, something like that. It's casting a shadow of 10 meters. The same time Juan is casting his shadow. So these are those similar triangles here. So we want to figure out how tall the wind turbine is. So these two triangles are similar. If you wanted to draw Juan right here, you could have, but I like to choose separate ones. So my scale factor here, I'm going to say, I'll put this one on top, this one on the bottom. 1.3 over 10 is equal to 1.9 over x. Cross multiply, you'll get 1.3x is equal to 19, and then divide by 1.3. Sorry, I ran out of space here. But 19 divided by 1.3, you get about 14 point, let's say, round to the 10th, so 6. So the wind turbine is about 14.6 meters tall. Just about. All right, 27 here, another similar triangles case. So here you put the 12 over 36, and it's going to be equal to the 9 over x. So cross multiply here. So you get, I'll write it over here, 12x is equal to whatever 36 times 9 is, 324. You could have simplified this fraction if you wanted to. That would have made it easier for me. But I'm just going to let the calculator do the work. Divide by 12. And so x is going to be equal to 27. And some of you would have been able to do it without calculating it. 12 times 3 is 36. 9 times 3 is 27. All right. So here we're going to take a look whether this triangle is similar. Justify your reasoning. It's very similar to our other triangle. We have a side, we have a matching angle, and another side. But here we have the side, the angle again, but we're missing the whole side here. But if you take a look, this angle here is the same in both the triangles. So it's going to be angle-angle similarity theorem. And then what is the length of BC? So now we could think about this. Here, I'm going to put 6 over, and then I'll put x here, and then it's over 4 over 12. So I'm going to do it a little differently, actually. So my scale factor, I'm going to say, is 12 over 4. And then this time I'll simplify it, make it 3 over 1, so it's easier for me. And then that's going to be equal to, sorry, and then x, by the way, is this whole thing, not just that little piece. So x over 6. And so what we end up getting, if we multiply this out, is 18 is equal to x. And again, that makes sense. 4 times 3 is 12. 6 times 3 is going to be 18. So this whole length is 18 here. Okay, for question 30 here. So 30 is very similar. You put your sides as a ratio. So for me, I'm going to put 25 over 15, and that's going to be equal to 20 over, and then I'll put AB this time. You could put X if you'd like instead. And then you could simplify, but again, I'm going to be a little lazy. You'll get 25AB is equal to 15 times 20, which is 300. Divide by 25 on both sides. And AB is going to be equal to 12.